Good day, guys. Today, I want us to learn dimension of physical uh, quantity. So, what is the meaning of dimension? We use dimension to relate one quantity to another quantity. It's very, very simple. So, when talking about dimension of physical quantity, they are um, some of the fundamental quantities that are very, very important when dealing with what dimension of physical quantity. So let's look at this. We have the phase one. We have the mass, which we are going to use capital M for the mass. The second one is the length, which we are going to use L. Three is the time, which we are going to use capital T. So why do we study dimension of physical quantity? We use dimension of physical quantity to check for number one, to check correctness of an equation. Number two, we use it to we use dimension analysis to derive units for a physical quantity. We also use number three. We also use let me write the uses of number three. We also use to relate is used to relate or let me put it this way, it is used to find the relationship between two or more quantities. So this is why we study dimensional analysis. That is dimension of physical quantity. You can call it dimensional analysis. So we use the first one, we use it to check the coordinates of an equation. Number two, we use it to check to derive a unit for a physical quantity. Number three, we use it to find the relationship between two or more quantities. So this is why we study dimensional analysis. So we are going to look at how we can apply this dimensional analysis or yes, this dimension of physical quantity to derive dimension uh, for derive quantities. So let's see. Remember this is time and it's t. So for example, if you are asked what is the dimension for velocity, this is the velocity. So velocity is given as what displacement over time. That is an s divided by t. So where you have s is distance. It's the same thing as saying length. So I'm going to replace it with capital L. Put the L here. So where I have time, I'm going to replace time with capital letter T. So we have this divided by capital T. So this can give us LT. When you remove this division sign, you are going to have LT minus 1. That is power of minus 1. So that is it. You can also use this to get the unit of this. Remember the second use of what dimensional analysis. We can use it to derive a given unit for a physical quantity. So if you want to derive a unit for this velocity, now remember this marker. Remember that L is measured, that its length is measured in meter. So this is going to be meter. Time is measured in second, that is going to be second. So raised to minus 1. So it means that the unit for velocity is what? Meter per second. The unit for velocity is meter per second. So how about for acceleration? A is equals to what? Velocity over time equals to, what's the dimension for velocity? That is LT minus 1 divided by T. You are going to put the law of indices. When they have the same base, this is TT, you subtract the power. So you are going to have LT minus 1. Here we have a power of 1 minus 1. So we are going to have LT minus 2. So it means that the dimension for acceleration is what? LT raised to power minus 2. Then if you want to find the unit, remember meter is measured in length is measured in meter, then time is measured in second. This is S, so raised to power minus 2. So it means that acceleration is measured in meter per second square. This is what it means. So it's very, very simple. So the same thing applicable to if I ask you dimension for momentum, or let me say force. Force is given as what? Mass times what? Acceleration. So for mass, I'm going to replace small letter L or small letter M with big letter M. So I have this. So acceleration is what? What is the dimension for acceleration? Is LT minus 2, LT minus 2. So it means that the dimension for force is M LT raised to power minus 2, which is the answer. So it is very, very simple. Very, very simple. So let me show you how to use dimensional analysis to check whether equation is dimensionally correct or not. Let's see. I'm going to use this. Let me show you this. Let's look at this one now. V, equation of motion equals to U plus AT. So what is dimension for? I want to check whether this equation is balanced or is correct. For this equation to be correct, it means that the dimension of the left hand side must be equal to the dimension of the right hand side. Let's see. Velocity is what? LT minus 1 equals to, this initial velocity is still the same thing as what? Velocity. So we have LT minus 1 plus dimension for acceleration is what? LT minus 2 times dimension for time, that is T. So we are going to have LT minus 1 equals to LT minus 1. Remember that this is T. Applying the law of indices, multiplication law, when the base are the same, you add the power, so you are going to have AX plus Y. Apply that same thing here. The power of T here is 1. So minus 2 plus 1 is going to give you minus 1. So plus LT minus 1. So you now have that LT minus 1 equals to, add these two together, we have 2 LT minus 1. So if you look at this, ignore the coefficient. If you look at this, the dimension that we have on the right hand side is equal to the dimension that we have on the left hand side. So it means that this equation is dimensionally correct. So this is where we are going to stop in our today physics class. Please don't forget to subscribe to my channel. Don't forget to follow me for more videos. Bye bye.